Want to do, you can put another generalized k-means by yourself. But here I will do a quick example right here. So I do some parameter setting before I did it. Okay, so right here, general, I would like to see more comprehensive data output. Okay, and here the number of clusters, it means you can define by yourself how many clusters you expect to see. Okay, of course it starts by 2. It cannot be 1 because 1 cluster, it means you do not cluster any groups. All of the members are in the 1. So you can choose 4 or 5 by yourself. There is no rules to identify how many cases should be identified to how many groups. So don't worry, it is not the kind of the trial and error, because in Statistica, even you set up the cluster number, it will give you a small choice. The final answer will help you to do that. Why? Because we will start up the V-vote cost variation. In algorithms, when we do the algorithm practice or running programming, you will also set up the V-vote classification. The result will be confirmed and more stable. So that's what we mean. Even you set up the higher number of the cluster, but the software, especially in Statistica, we will give you the best suggestion for the cluster number, because when we see the training progress is converged, it's more converged and more stable. So you just start up this function for V-vote cost variation, and this is folder is default setting by yourself. Okay, this is a random seed starting by 2 up to 25 cluster. Of course, this function is starting by 2. You already know that. Okay, and then we go back to the general setting, comprehensive cluster 5. You can also set up for how many iterations you want to do. Okay, and then set up 2 for sorting the members. Okay, so for example, right here, if you set up the cluster number for 5, that means maybe the final answer will be 5 cluster, maybe 4 or 3. I don't know. We will make sure after running it. But Statistica will sort by the case, by the number. The cluster 1, what is the case? Cluster 1, cluster 102 or 2, or for example, you sort it, and we measure it. Okay, so let me know if you all follow this way. Okay, you will try to run, but what else?
Select variable.
Yeah.
Dependent and independent variable.
Yeah, we don't do that, right? Okay, thanks for Professor. He already answered my question. But how to set the variables, dependent and the predictor? This is a cluster analysis. In data mining, we call it unsupervised learning algorithm. So what kind of variable you need? Dependent or independent? Unsupervised learning, you only need to set up for independent. You don't need to set up for dependent. Why?
Because they are not supervised learning. Do you remember in multivariate I mentioned about, you just decide one side, okay? You just choose one side, okay? Clustering, no dependent variable, okay? You just focus on case or just focus on variable.
Okay.
Okay.
Go ahead. So here, I would like to give you some additional hint when you run Statistica Workspace. Right here, there's no option for me to select the variables. Right here, and you go back here, you can double click to set up the parameter, the variable right here in Statistica data file directory. But I would like to show you another hint. Maybe some of you already tried it before, but here I would like to let you have the experience. When you see the note with the SVB, some algorithm they will put the SVB in the note. That means that kind of the process node will not have the location, will not have the option for people to set up for the variables directory. So that means you come back to your original data file, highlight it, and go to the data. And go to the variables. There's one option we call select variables. Right here? Okay. What kind of a color for this node? It's also green, right? So that means you can make these two nodes just like one. It's still motivated on the data file directory. So I can do some parameter setting right here, still for variable selection. And right here, you know the dependent, you know the predictor. Predictor, either this way or this way, there are 4 X. That's the professor he mentioned. We just, for one side, we don't have to for another side for the result. So we choose all the options right here for 1 to 14. For dependent categorical, because Statistica will also search your original data file. If the contents are not in numbers, that means the data is not continuous. They should be identified as categorical format. Okay, we keep other column as blank. We don't have to do anything. We could click OK and click OK again. Okay, so what is next? We move this line to this line. Do anyone ever did this before? Move the line. You just use your mouse.
那个线拉来这里，它是先经过选择变数。You can select the variable, just one of these functions. Select just a field.
Okay. So since here is the modify the note, so you can run modify or run this way first. Okay. Don't forget to remember it. And now you can run the generalized EM right here and wait for the answer. Okay. So this is a kind of unsupervised learning algorithm. We only operate on the X variables. But we also image can consider there will be a second-hand output answer be generalized after cluster. What will be the possible answer? Let's check the raw data again. The original data is 15 variables and 8,900 pairs. But right here we only involve 14. The first of 14 variables, because the last one is just for sample identification for channel tester. We don't use it. Okay? But when you go back to your new data file generated here, you can check it. Okay, it's 17 variables, but it's 68.
68.
Yeah. Okay, I'm sorry. I mentioned you said 63. Yeah, but it also makes sense to us. I already delete over 2,000 cases. So now you can understand. In the previous hours, we discussed, wow, if you are the data owner, you already pay for the data collection. You waste 20% information. Okay? Oh, let's go back here. Oh, sorry, too fast. So here we have two additional variables generalized here. So we can move to the last. Okay, because the first 15 columns, they are copied from the original data. They are the same. They are the same. But there are two additional variables generalized. One is called final classification. You can see the content is starting by 1, 1, 1, 1, 1. Why? Remember, when we do the parameter setting, we ask the Statistica to sort by cluster. Right? So it was starting by cluster 1, and then move to cluster 2, and move to the blah, 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 something. So we use the same skill. Double click, we check the value set. Okay, there are 3 clusters. Okay, remember how many cluster number I set up? 5. But here, the better choice to suggest use 3, because after we after we do the EM algorithm, Statistica is found the converge is happen after you classify by 3. For the fourth and the fifth cluster, it doesn't be so obviously to be classified. So you give us 3 clusters. Remember, this is because we set up for V4 cost variation. Okay, V4 cost variation is a way to help us to do a quick converge progress. Okay, without it. Okay, but there is one more information we can learn from here. Okay, this is 1, 2, 3, right? But we all know it should be cluster 1, cluster 2, and cluster 3. There should be numbers or format in categories. There should be categorical format. They should not be the numbers, right? Okay, but we still can read here. First of all, let me tell you. For these 3 information, they are follow the descriptive statistics. That means only your data is continuous, so it makes sense. But we still can use that, even they are categorical format. Why? You know, the mean is 1.8, right? 1.8. What number is close to 1.8? What number is close to 1.8? 2, 1, or 3? 2. And 1.8 is between 1 and 2, right? Below 2. So now, before we check the final answer, you can tell yourself, for cluster 1, 2, 3, which cluster has the last members, and which cluster has the more members? 2 should have the more cases, right? What is the few cases? 3, because the average, the mean is under 2, right? So, but we can double check later, right? But they also give you some information, some sign right here. Okay. Okay. So we go back here. We will use these 2 additional variables used. So let's go back to the last column. Is probability. Okay. The EM algorithm is to calculate the PI. So we want to know the why we can use the probability. Okay. Now we know the cluster 1, cluster 2, and cluster 3. Based upon how many members are assigned to it and it or it. So we will have a new probability. Okay. So we will take this one for Y dependent, a continuous dependent, and we will use this one for our only one categorical X. But this one again is identified by 1.000 and 2.000 and 3.000. So in Statistica, by default, it can be defined as numeric or data. So what can I do? double click. Remember this function? Test label. Okay, you just click it. Now you can create by yourself. Cluster 1. What is the match number? By default, it starts by 101, but don't worry about it. You just click a 1. Enter. Two. Enter. 3. Enter. So after this operation, the original column, after variable 16, all the data assigned to 1.000 will be revised, recode to cluster 1. Okay, and okay. So I rewrite it. So again, you don't have to reset this file. Even you do some modification, you are here, you just close it because this file is right here. I just make sure this new file is also enabled inside the whole workspace. After I move it, I just save all the nodes once. Okay, so right here, how I can do? I would like to, like I show you on the whiteboard. After cluster, I would like to do the one-way ANOVA. So here, you see the data. The color here and here, they are the same color. In Workspace, you will see the node. The color is in green. It means it's the data source node. So I can collect it here. You can see, okay, there are two options here. One diamond here, one diamond here. One receive here, one receive here. So they are the same format, but different content. But I can highlight and go back to the statistics because I want to do the one-way ANOVA. One-way ANOVA is right here. We also call the main effect. So main effect ANOVA means no matter how many S variables you involved, you also you only concern their main effect. You don't consider if they between them has any interactive or not. So one way is still the follow the same. So I follow here. Okay. Do you see the SVB here again? What I mean? I need to go to the data, variables, select variables again. Put it here, make a connection here, move the connection here.
Select the variable SVB.
SVB. Okay. SVB means Statistical Visual Basic. Yeah. Because Workspace is under the product we call Statistical Data Miner. The first release of Data Miner is over 15 years ago. So after year by year, the software itself will have different kind of the upgrade, the versionization, but some notes, if they are still workable and practicable and still helpful, they will keep us the original way. So the old version, we call it SVB. We still keep them. We don't change their format too much. But there are some algorithms we develop, but we also do some optimization setting. We don't have to set up for SVB because some nodes, we already involve the variable selection inside the node directory. We don't have to do that. Okay. So right here, we have to celebrate the variables again. When you click here, variables here, you see what is the difference. In the previous dialog, we don't see these two variables right here, right? Okay. Final classification probability. Okay. But you still can see the final classification is belonging to the continuous. Wow. But I already do some modification, right? For cluster 1. Let me check the room. Okay, I already identified it. So don't worry about it. What you can do is right here, on unclick, unrelease this function, because this function typically is designed for helping people. After you identify, you do a full identification for your data, categorical or continuous. At least when you do the label selection, you can save your time not to check all of them. But here we will do a better option here is to unrelease this function. So we move down. Okay, the continuous should be our probability. Okay, we can also check a room. Oh, the probability is starting by 0.47. The highest is 1. Okay, this is good job. We want to do that. And our predictor is the final classification. That means we use final classification in the app to identify, just as I show you on the whiteboard on the right side. We have 2 clusters. But we want to make sure if the member assigned to name are really do a good result in celebration name.
So what is the hypothesis? What is the hypothesis here? Dependent. What's your study purpose for this job? 做这个动作的目的是什么
What are the mean of cluster differences? Is significant.
Once again,
Mean of different 3 cluster. Mean of.
yes, the mean. Each cluster of the mean are equal now, right? 做这个动作的目的是要比较什么
Okay, let me drop it to you. Okay. This is our cluster 1. Our central right here. This is our cluster 2. Central right here. This is the cluster 3. Central right here. Okay. For example, there is a member coming. Coming here. The member here. Member here. Okay. So based upon the member already assigned here, they should be have the shortest distance right here, right? And for the other 2 centroid, they should be the farthest distance. So that means this member assigned here are pretty make sure they are separate from the other 2 clusters. So I make an example right here. If there is a member coming here, I'll calculate the distance. I'll calculate the distance. In average, if this distance equal to this distance and also equal to distance, the hypothesis testing will be mu1, mu2, mu3. The mu means the distance of member K to centroid 3. This is the centroid distance between the centroid 2, and this is the distance between it and to the centroid 1. Okay? So if this distance, if this hypothesis is achieved, is true, that means it can be assigned here, and also can be here, and also can be here. So that's what I mean. We do not do a good celebration for this member. It can be any cluster, right? So that's why I mentioned here on the right side. Our mission is to reject. Our mission is to reject the new hypothesis. This is our job. At least, for this case, there are 3 clusters. At least, if I reject it, that means there will be an easy job. More easy for me is, yeah, you can say, maybe if I reject the new hypothesis here, It can be here or can be here. Do you follow me? Okay. Let me tell inventory maybe perfect 一个 check it for。我的意思是说，如果我们拒绝了虚无假设，至少我可以知道这边可以2分，那我这边可以用 post hoc， 可以用 post hoc testing。
That means the new member from the centroid of each group, not all equal. That means, yes, I have 3 boyfriends. I love which one is stronger than the other, right? The distance is not equal, okay? EM is better for categorical data to do the clustering. And now you want to make sure, are you love your 3 boyfriend equal? No, you had better reject, not all equal. That's the general boyfriend, this is my fiancé, okay? And the distance is more close than the other boyfriend, right? Not all equal. That's it. That's why we want to prove our result. Is much clear?
Yes.
你的3个男朋友没有一样的距离，你特别喜欢某一个 ，OK？
Of course, this is a good example. For the gentleman, you can imagine you have 3 female good friends. Also, all right. This is the same way to think about. All right. Okay. So we do that, and also make sure again. There is one more thing. After we do the setting, we will see the variable selection here. We have to rerun it, but there's one more important option I have to mention you for this case study. Okay. Personally, I think that will be the critical part for the whole project. You just go back here again. Sorry, should be right here. Okay. Data for deployed project. Do not re-estimate the models. You just make sure this option is click. It's select. Let me tell you details later, right? Just okay. So we rerun it. And then we can run it. The result will come back here. Why this option just for the deploy project is so important? Because this node is follow this one. So they can see they are the one thing about the data multiplication, data selection, right here. Just like we do here, right? But this is our raw data. This data is generalized after we run the EM algorithm. So the variable selected here is quite different we selected here. So we use this function to identify to tell statistica. Here is here, here is here. They are quite different variable selection. So if you do this setting, it doesn't matter if you start by here run O, run multiply, or run here. The answer after this part will be unique. Just only follow this data file and follow this kind of format of data analytics. It will not be affected from the previous image, from the previous progress. Okay, this function is right here. Double check again. Do data for deployed project. Do not re-estimate method. Because the previous, what we done in previous step will not affect what we do here. Okay, so let's check the answer. Okay, so the quick answer for the ANOMA table is to check if the p-value is achieved significant or not. Okay, so right here, the previous data is 0. Oh, sorry, the p-value is 0. It means it is significant. So we have to reject the null hypothesis, and we can make sure at least this cluster result should be 2 or more. Even in EM algorithm, it tells us 3, right? But let me show you something. Now we reject it. Okay. What kind of the possible situation to reject the new hypothesis? mu1 not equal to mu2. Yes, we reject.
Multiple computation.
Yeah.
Shafe or Bernoulli, right?
Yeah.
Not all equal, okay? I love my 3 boyfriend, not all equal. But you love one more, or you love the other 2 more than the one, right? So you must do multiple computation, pair computation, 多重比较啦，Shafe or Duncan or Bernoulli.
Yeah. Oh, we also call
Yeah,
it
you
post.
know
We also call it post hoc.
Post hoc.
So I list down 4 possible options to reject the new hypothesis. Okay, either 2 or maybe all of 3. Okay, so but there will be another story. You can go back to the one way or another and click on the option to get the result. But right here, you can say, okay, we already got the result. Okay, so what's next? Now I will be confident move to the check the cluster result. Maybe some of you will be wondering, yeah, why I do the cluster analysis? I don't go to check a result immediately, because I want to show you only you have the confidence from the one-way ANOVA result. You will understand, yes, Statistica suggests me the cluster number 3. Although I set up for 5, it's reliable. Okay, that's why I try to imagine you garbage in, garbage out. Yes, we know that. But if I make up a beautiful packaging garbage to you, can you identify? All right. So let's go back here. We check the result. Okay. This is the priority probability. Okay, this is the graphs. Okay, they show me this is like the PCA progress. We call this screen plot. Starting by here, it's going down. The screen plot means your progress is starting to be converged. So the best option will be cluster 3. Okay, this is the cluster member. Now you can see, okay, what is the best background about the cluster 1, cluster 2, and because we follow the one-way ANOVA. Of course, the data information we generate the result we get here is not rich enough. So you can go back to remodify your parameter setting. For what? I can choose my result from comprehensive to all results. Statistica will show me more graphs for each select variables to show me these 3 clusters, how they distribute between the cats. And we can also get here, we can tell Statistica, yes, please give me more information about the one-way ANOVA. Also the hypothesis testing about the homogeneity. And also show me some graphs. And if you want to do some residual analysis, please do that. You want to check the normal probability part, please do that. And do it again. And then rerun. Oh. So I do this case study for today. I can show you the rest. It means, of course, when I use the Workspace, it's pretty powerful for me to record all my workflow about my topic I select. I can run a lot of process node, including the discrete statistics, to machine learning or some data mining algorithm. I don't worry about it. But remember, we already mentioned 2 times. We already know garbage in, garbage out. But if you are really want to be a data scientist, you have to train yourself to have the ability to avoid any kind of the beautiful garbage you can point out immediately by yourself. So it doesn't matter if you have to check all the results in the first time. Maybe for the cluster analysis for this example, you follow the one-way ANOVA. You already got the answer you expect to find out. And then you can go back to run Workspace again, but put the output from the minimal of the comprehensive to the all result. Because you already earn yourself more time to check the detailed reports data. You don't have to waste your time, you don't have to spend your much time to run a comprehensive all the result in the first time. Because comes out, right? Again. So this is my personal experiment, I can show you that. So in the first session, remember what's hint to the third hint, what's that variable selection, and remember to click the deployment project, also check the missing data. They are pretty more small hint skills, but they will reach your research problem. Okay, that's what I can show you today. But next week we will go more details. I'm sorry because it is still far away than what I want to do today, because I have a plan to show you another case study. But when we take a break, I think maybe we can move to next week, because the next case study is about credit scoring. I check your midterm. Some students you already do the credit scoring case. It's pretty nice. So next week we can discuss more about credit scoring by that. But I will show you another case study, another interesting tool owned by what we call the test mining.
Yeah,
but I still need to take time to take a review, because as I mentioned, the data miner, the original name of this software, is first released over 15 years. So after rewriting, modification, there are some data are not exist. Okay, I already prepared one test miner example from the old data here. We call the routers, a digital news publisher from Rutosa. Okay, but from my installed Statistica on my machine, the data file are moved. I don't know, but I'm not sure if you already have the data right here. Maybe later I can take 1 minute to have a quick look. If we still have the data right here, we can use it. Okay. All right. So I hope you will have a good and useful experience with me today. Okay. I would like to show you more, and then see you next week.
Okay.
Okay. Thank you.
Yeah.